Good afternoon, everybody. You're very welcome today. Today we're officially launching our MSc in Bioinformatics. So thanks for joining us today. Before I introduce the panel that we have in front of us, just a small bit of housekeeping here. So we are now recording this webinar, and the recording will be shared on the ATU social media web pages and emailed to the attendees today as well. There is going to be a Q&A session at the end of this webinar. However, if you look to the top there, you'll see a Q&A box up above. So if you come across or if you want to ask a question, you can just pop the question in there and we can answer that near the end of our session. So our session today is going to last approximately half an hour. And today with us now, the panel we have in front of us is Mr. James Mawhinney, and he's the head of Genomic Strategy at Randox Laboratories. And he'll be giving us an overview of Randox and what they do in Randox. With James, we have Dr. Cormac Rice. He's a Bioinformatics Team Lead at Randox, and he'll be describing his role as a bioinformatician at Randox. And then we also have Dr. Paul Higgins. Dr. Paul Higgins is a lecturer at ATU, Donegal, and he's also the program chair of this new Masters. And he will be giving an overview of the Masters and how you can apply for it. Okay, so we'll start now with James. So James, if you want to share your slides on the screen, and I'll pass the mic to you.
Perfect. Thank you very much, Kim, for the introduction. And I hope everyone can hear me okay. Let me just get up my wee slides here. Everyone see that okay? Kim, give me a nod. I can see you. Yes, perfect. Thank you. Yes, so as Kim was saying, my name is James Mawhinney. I'm the head of Genomic Strategy here at Randox. I've been working with the company maybe for about 5.5 years now. Starting off in research and development, and then COVID kind of kicked off and we all got brought into the COVID testing lab. So that's where the next 2 years of Randox took me, working in the PCR labs. And then there became a requirement then to do we were testing all the positive samples to see what strain they were, to find out if it was Omicron or Delta. And I have a little slide on that a little bit later to kind of see some of the data that we got out of that. And then from there, our sequencing facilities really expanded. We got a lot of new infrastructure and a lot of new analyzers in. So we've really grown our sequencing department. And then with that, the bioinformatics department has grown as well. So within this slide, I'm just going to give you a little bit of an overview about Randox, about who we are, what we do, some of the areas that we work in. And then I'm going to hand over to Cormac Rice, who's going to talk to you a little bit more in depth about the bioinformatics side. So just brief overview about Randox. We're the UK's largest diagnostics company. We also work out of Ireland as well. We have a little site in Dunloe that's usually used for manufacturing. And we were established in 1982, so we've been around a good while now. We make 4.1 billion diagnostics tests annually. And we basically diagnose about 5% of the world's population through different tests and different platforms across the world. Throughout the COVID pandemic, we were making about 27 or 26 million COVID tests. They all came through our PCR labs. There was a lot of other lateral flow tests as well. And we supply about 100,000 labs globally. We work across the world, as I was saying. We've got a main hub in Dunloe for manufacturing, but we also have distributors and sales offices around the world. So no matter where you're kind of based, we have a team there. This is just kind of give you a little bit of an overview about the whole scope of Randox. We're involved in a lot of different areas. We're involved in Randox Health, which is kind of our direct-to-consumer brand. You'll see a lot of clinics, especially if you go into the UK. London, there's about 10 in London, and then across the UK as a whole, there's about 27 different clinics that you can walk in, get some blood tests done, and different things like that. We also sell reagents. Food testing is another one we do. We do a lot of milk testing, meat testing, things like that for a lot of antibiotics or certain toxins. RTS, which is a testing service, that's toxicology. So it's looking at like into coroners' offices and drug overdoses and things like that. We make a lot of instruments. That's where the evidence series and the RX series is coming in at the end. RCLS is our clinical laboratory services. So that's looking at all clinical tests. So we work a lot with universities, and with pharmaceutical companies and biotech companies to basically do clinical trials through our labs. Biosciences is the department that facilitates that as well, so they kind of make end-to-end bespoke services. We can help design and make it diagnostic tests through that department. And then there's also point of care instruments and quality control. We do a lot of quality control reagents, controls, and EQA proficiency schemes as well. So it's a very diverse company if you can't get from that slide. In terms of a little bit more about my role, so I work within Randox Health, and we basically operate a lot of Randox Health clinics across the UK, as I was saying. We also have one in Dublin and Sandyford. Within that, we offer genomics products, which I'll talk about next. So within the genomics catalog, we do a lot of cancer and cardio screening. So that's probably the main component of our business at the minute, is looking at clinical diagnostic tests. So we're looking for BRCA1, BRCA2 screening tests. If people aren't able to go through the NHS, or if the NHS is too slow, then they'll come to us privately, and we can offer that testing. We also do a lot of microbiome tests, as well as the more lighter side of genomics that's not so clinically focused, looking at your lifestyle tests, which is going to go over some athletic performance markers, some nutritional markers, and then some general health and well-being markers. So it's a really, really nice package that kind of suits the direct-to-consumer market in a nice, friendly way, and not so serious on the clinical front. In terms of how we stand in the genomics markets, this was a really nice publication put out by BIA, Catapult and Sanger. This was in 2021, but it actually recognised Randox as a main hub of genomics within the UK, which is really, really nice to see. You always kind of think of genomics hubs being centred around the Cambridge, Oxford area in London. But it was really, really nice to see this massive blip on the radar for Randox in Northern Ireland. And then this is the COVID data that I was talking about earlier. So during the COVID pandemic, we sequenced and genotyped about 250,000 samples, which is a huge amount of data. And I think we're basically sequencing the whole genome of these COVID viruses to find different mutations that are cropping up, and to kind of track the spread as it comes into the country. And we were reporting all that to the UK government so they could track the spread and influence lockdown decisions, or ignore that advice and don't go into lockdown. We were doing about 5,000 samples a week, and this is some of the really nice data. So you can see here, this is over the space of about 2 weeks, and you can see how quickly the shift between the Delta strain and the Omicron strain kind of came into effect. Like over the space of about 10 days, you had a 95% abundance shift between the two strains. So it was really crazy to see that data, just how quickly these strains changed coming into the country. And then just to kind of finally hint on to some of the instruments that we have at Randox, we have the NovaSeq 6000, the NextSeq 2000, and the Illumina MySeq. They're all Illumina based, and they're kind of like the low throughput, mid throughput, and high throughput options for sequencing, and it's kind of often referred to as the gold standard of sequencing technology at the minute. There are a lot of other kind of players coming into the market, but we're very still Illumina based. So that's a very brief overview. I don't think I've got too much. No, that's me. So very quick, rapid fire round about Randox. So I'll pass over to Cormac now, and he will probably talk through my screen, but present on his. Yep, I can see it.
Video, so hope you can hear me okay there, folks. As James kind of introduced the overall kind of scope of Randox and the service we offer, I'm going to kind of more focus in on the bioinformatics side of things, kind of services that we've helped to develop and they're kind of offered out to clients and customers. So in the team lead at Randox, for the bioinformatics team, we have a team maybe of 12, 13 kind of staff, and we all kind of work in different areas of the bioinformatics field. I myself more focused in microbiology. Some of the team are focused on RNA sequencing. Some are focused on cancer cardio kind of genetics, whole genome sequencing, things like that. So really it's quite a diverse team. As you can see there, some of the kind of services we offer. So at the minute, one of the most popular ones we have gut microbiome analysis. So from that, we're kind of taking stool samples, obviously go through the sequence in the wet lab stage, and then we kind of take the reads after that, quality control them, and then classify certain reads towards bacterial databases to allow for that taxonomic classification. On top of that, we're also able to classify some viral components, archaeal components, and then additional some fungal components. On top of that, again, we look into kind of the antimicrobial resistance profile of samples. So again, in the gut, we can kind of like profile for clients and stuff, AMR. So we can kind of spin that out, which is nice. And then in terms of our general environmental samples and stuff, we can kind of do AMR detection and that too. So that's hand in hand. That's quite a nice service, a nice bit of R&D we kind of developed here at Randox within the Bioinformatics team. Other things we kind of work on, pipelines we have for pathogen detection, nutrigenomics, pharmacogenomics, whole exome sequencing, whole genome sequencing. I say it kind of spans across many different fields of the life science and medical kind of realm. Again, some of the team are kind of focused on RNA sequencing, and even have teams focused on like methylation analysis of DNA. And one of our bioinformaticians is quite heavily focused on proteomics, and that's kind of a nice collaboration we have going with Olink and stuff. So say we are quite focused on a wide array of different types of analysis and services for sure. So yeah, some of the techniques and infrastructure we have around that. So obviously it's nice to kind of have, you know, the bioinformatics services and stuff, but in terms of actually being able to provide these services, we have to have the infrastructure behind it. So obviously for that, you kind of need very high spec computers that are capable of doing certain types of analysis. So Randox we kind of designed and built like our own in-house HPC. So they have each kind of cluster and stuff would have its, you know, its own nodes, each with different types of RAM, CPUs, GPUs, and stuff. All that's quite important to actually facilitate us to perform these types of analysis. To use those, then we have highly trained bioinformaticians, all capable of using things like Python, Bash, R, Java, nice scripting languages help us automate and kind of perform those types of analysis. On top of that, sometimes whenever you know your on-prem kind of resources are limited, or maybe you need to branch out into a more diverse kind of analysis platform, we then make use of the cloud platforms, so things like Azure, AWS, and the Google Cloud platform as well are all quite beneficial to have. And sometimes we can spin them up as kind of a hybrid analysis platform. So it's 50% on-prem, 50% off-prem and stuff. All the things we kind of commonly use, one of our bioinformaticians is quite specialized in, is kind of setting up user interface and database servers. So that's things like Postgre, RShiny, RStudio, pgadmin and stuff. So if he sets it up, it means other users can log on, perform their different types of analysis of whether it's based on databases or different types of in-house apps and stuff, which is quite nice to have. And of course, you know, being bioinformaticians, there's a large element of the software engineering side. So obviously things like version control of code is quite important and stuff. So we utilize things like GitHub, Bitbucket, Git, and some of the Azure repos for version control and stuff. So we'll just chat you through this high performance computing kind of aspect that we would utilize quite heavily in the team. The way that works, if no one's quite familiar with it, is comprised of several worker nodes, and again, it tends to have one master node. So you submit most of your jobs from that master node, and it's kind of split up across your worker nodes. Say each node has a specific amount of RAM, CPUs, GPUs, and a certain element of storage. Again, you kind of try and set up these clusters in that each kind of node would have relatively the same kind of storage, memory, CPUs, GPUs, and stuff. It's just for more optimal processing, really. And then basically users will then submit their analysis using a submission script. We kind of would be using like a task manager such as like Slurm, but again, there are alternatives to it. Together, the nodes communicate via that job scheduler to process the user's analysis. And again, depending on whether or not, you know, a user wants to, if it's a big job, it's going to take a lot of time and stuff. The task manager will be able to kind of look at that and assign things into a priority, which is quite nice too. So if someone's job's going to take quite a lot of time, they might wait and it'll be run overnight, whereas jobs are maybe of higher priority kind of run during the day and allocate more resources there and then. But it's nice kind of have that side of it too. The job center is quite handy. As I say, I want to touch on the role of cloud computing in bioinformatics. So again, obviously buying your own on-prem infrastructure could be quite expensive. You might also need like a Linux administrator and stuff to set that up and kind of have like run maintenance of your servers and stuff. So a nice workaround approach to that is maybe a cloud computing where a lot of your analysis and stuff, and maybe virtual machines are set up on a cloud-based system. But then as I say, you can also have a nice hybrid setup. So 50% of your resources could be on-prem, whereas 50% of your resources could be based in the cloud system. So you have like 1 or 2 Linux servers on-prem, but then spin off virtual machines into like something like Azure, AWS cloud, run your analysis there, and then store it in like something like an S3 bucket if you're using Amazon, or a storage container if you're using Azure. And it's easily accessed. It can be downloaded to your local workstation quite easily and quite quickly. This can be considered quite a cost-effective solution, again, depending on user requirements. If you're needing to do a lot of molecular modeling, spin up a lot of GPUs and stuff, well, then it might be quite expensive that way. You need to look at alternative options. As I said, also just spin up things like, you know, virtual machines, database servers, data warehouses, and data lakes and stuff. All kind of depends on the type of analysis that you're looking to do. Yeah, hosting your analysis, your applications in the cloud-based servers removes the need for any web design knowledge. So if you wanted to spin up an app, for users to interact with, or clients to interact with, you can host those on Azure or AWS. So you don't have any responsibility of setting up any web pages, and all the cybersecurity element of it is removed, which is quite nice. Azure or AWS will take the responsibility for that. As I say, most of your data is stored in either buckets or containers, so it's all kind of stored in highly secure cloud-based storage systems again, which is quite nice. And having that cybersecurity protocols implemented removes the need for on-site cybersecurity experts and stuff. So this slide just to kind of give you a quick run through of a typical workflow for some of the NGS data we've been having here. So obviously the wet lab guys will prep the samples, perform the library prep and stuff, and the sequencing reads. Once it's loaded on the machine, those reads are generated via a conversion of BCL files. So they're your base calling files. They're kind of generating the FASTQ files, and that's commonly performed using, so like if it was Illumina, they use BCL convert and stuff. So it just takes your raw files and kind of translates them into nice sequencing FASTQ files that then we can use and interpret. Before using the stuff though, obviously the reads need to be checked for different quality control metrics. So we have a general rule. Obviously it tailors and differs a bit depending on the type of analysis, but for something like a 16S analysis or microbiome analysis or shotgun metagenomics analysis, kind of things I'd be more focused on, we would trim the reads to a quality of 30. So that means all your reads are trimmed. Anything below a quality of 30 gets trimmed off and left behind. And that's using tools say like FastP or Sickle to perform the trimming and stuff. Once you have your reads trimmed, then they can then be used for different downstream analysis and stuff. So you have things like variant annotation, taxonomic classification, AMR prediction. If it's more protein focused, it's protein sequencing, it's be focused towards protein predictions. On top of that, you can do biomarker discovery. Again, that's a very generalized workflow. If it's for a certain project or certain type of analysis, you would then change the downstream steps after that. But the starting process of generating FASTQs and performing the quality control steps kind of tends to be the same across many different types of analysis. Then just to reach on, obviously the big thing these days now is becoming this machine learning, AI, kind of deep learning type of computing. I'm trying to integrate that into bioinformatics and the medical field and stuff. There are challenges with that. It obviously takes quite a long time to train an AI or deep learning based model, but it has been done. It's improving the work successfully in many different instances. So it's quite nice to see that, and that's some of the stuff we're trying to implement into the work here at Randox. So say some of the deep learning models you can be used to analyze large genomic data sets to identify different patterns. It's nice because some of the machine learning models can identify patterns that wouldn't be so easily identified by a general bioinformatics user. So that's maybe you want to use things like TensorFlow or scikit-learn and stuff. They can kind of identify hidden patterns that might not be so easily identified, say, by a general bioinformatics user. A very common one at the minute, if people are kind of interested in molecular modeling or kind of protein structure and stuff, it is AlphaFold. So it's using AI-based algorithms to predict 3D structures of protein. So in a sense, that's helping to remove the need for X-ray crystallography and stuff. But again, these are predictions, so you would want to be doing your wet lab stuff on top of that. But again, having that these high accuracy models now for protein discovery and stuff can help to predict new functions of proteins and aiding in drug discovery. And again, something that we maybe not touch on so much here, but like it's being used heavily in the medical field for basically analyzing images, which is quite nice to see as well. There's been a few papers published over the past few years kind of showing the success of AI machines in diagnosing diseases based on certain images and stuff. So it's quite nice that way too. And it kind of all is going towards the realm of personalized medicine, which is kind of an area of the medical field that Randox is kind of heavily involved in and stuff. And that's a lot of text, I know, but I just wanted to put it out there so you can read it in your own time and stuff. So obviously precision medicine, it's a medical approach that tailors treatment plan to individual patients based on their genetic, environmental, and lifestyle factors. And that'd be one of the places like the pharmacogenomic stuff offered at Randox. It would be quite a nice one to utilize in terms of seeing like what kind of drugs would be more sensitive to or resistant to and things like that. So it's kind of nice to see how the R&D here and stuff and the kind of processes we're implementing are going to be utilized to the benefit of clients in terms of their healthcare and stuff. So as I said, genomic sequencing and bioinformatics tools are processed for whole genome sequencing and stuff. We've chatted about that. For biomarker discovery, there's different algorithms to identify biomarkers, and they can help get like maybe as an early prediction of for certain diseases and stuff, which is kind of nice. In terms of disease stratification, some bioinformatics can help to enable classification of patients into different groups, and that kind of can then be utilized to say, okay, drug X, maybe these set of patients is not so effective on, but drug Y tends to work quite well in these patients, again, depending on the molecular or the genetic makeup and stuff. So it's nice to kind of have, even just to be aware of, that's kind of one of the roles of bioinformatics in kind of personalized medicine, is that disease stratification. Then just some examples, I guess, of the personalized treatment plans based on, say, genetic data and stuff. Breast cancer, for example, very common. Genetic testing for BRCA1, BRCA2 mutations that can help identify patients who are at a higher risk for breast and ovarian cancers. Say patients with them mutations may be able to receive personalized surveillance strategies, and maybe some preventative measures if obviously the mutation is diagnosed and stuff. Similar for lung cancer, some of the mutation rearrangements in small cell lung cancer can be used to, again, more targeted therapy. So knowing that information might help clinicians to diagnose or how to treat diseases in a different way that might have a more promising prognosis or outcome. Same for melanoma, HIV, and hepatitis. Something like HIV, genotyping of HIV can help determine resistance to antiretroviral drugs. So that, again, helps the clinician decide which kind of antiviral drug are we going to prescribe here to help treat things like HIV. So knowing all that kind of information kind of helps to build a profile about a client or about a customer and stuff, and that's kind of how we're fitting in with the personalized medicine field, trying to tailor these kind of genetic data and types of analysis we do towards, let's say, personalized medicine and those services that we offer. Again, just to finish off, if you're interested in learning more about the role of bioinformatics and the testing that's kind of going on at Randox, you have Emmanuel's email there. He's the head of bioinformatics. You have myself as Bioinformatics Team Lead, and of course you have James Mawhinney, head of Genomic Strategy and stuff. So feel free to reach out to us if you're interested in chatting about roles and stuff, or more of the research, maybe even some of the tests and services that we offer. Feel free to reach out or say drop a follow on the Randox Instagram page. There's some quite useful stuff there to keep you updated on what's going on top of that. But yeah, that's probably all from me. I'm happy to answer any questions if someone wants to email privately or chat about it afterwards. No problem at all.
That's great, Cormac. Thanks very much for that. It's very interesting the way the word is going now in terms of personalized medicine and the role of Randox in that. Well, we might move very swiftly on now to Dr. Paul Higgins, and Paul's going to give an overview of our new masters and how this will prepare students and graduates for the world of work at Randox.
Okay, thank you very much, Kim. Hopefully you can all hear me. Yep. Okay, thank you very much. Just bring my slides up here. So I'm going to talk today about our taught MSc in bioinformatics that we have developed here at ATU. This MSc is going to be fully online. We also have other postgraduate offerings within the broader MSc, a postgrad cert and diploma. So I'll introduce to you a little bit about how this program will work. Okay. Sorry, my slides are not behaving too well here. Okay. So hopefully you can still see my screen. Yes?
No, Paul, no, we
No?
can't see your slides
Okay.
at all.
Bear with me. Okay.
Yeah, we're back on track now.
Now we're back on track.
Perfect.
Okay,
yeah.
Perfect. Okay. All right, thank you very much. So I'll talk about a couple of things today on our MSc program. Why bioinformatics? Why bioinformatics at ATU? I'll show you a little bit of what you could expect in this program, and then talk a little bit at the end, very briefly, about where you could go with this type of qualification. So firstly, generally, why bioinformatics in general? So James talked a lot and Cormac talked a lot about omics data in their presentation, the flood of genomics data that is now coming into many different disciplines. We have genomics data hugely important in drug discovery and development. We have, as mentioned, genomics data crucial in personalized medicine and indeed in public health and medicine policy now, both in Ireland and indeed globally. We also have this type of data coming into areas like food tech and agri-tech also. The skill set required to handle this data is, of course, a bioinformatics and a computational skill set. Most traditional biological sciences programs do not provide training to be able to handle this type of data. It is really, in many ways, a new skill set. It's an interdisciplinary skill set. And having that bioinformatics, that computational skill set is very much a way to future-proof, to prepare yourself for a rapidly changing landscape in the biology domains. So very much the watchword for why bioinformatics is future-proofing. Preparing for the future. Why bioinformatics at ATU? Well, very briefly here, I'm going to talk a little bit about some unique components of our program. Firstly, reflecting that interdisciplinary aspect of bioinformatics, the program has been co-developed and will be co-delivered by both the Department of Life and Physical Sciences and the Department of Computing. So the biology components will be taught, of course, by the life and physical scientists. The programming and computing components, which are crucial in bioinformatics, of course, will be taught by computer scientists. And then there will be a deep interaction and relationship between the two, both contributing to the different aspects of the taught components. Secondly, we have leveraged a lot of input and expertise from industry experts and academic experts, not just on the island of Ireland, but also globally. And that input has been embedded in what we currently have, and that sort of input will continue throughout the development and the ongoing evolution of the program as well. Third, very important component of what we've built is that we've built this, and it has been built by and in collaboration with people who have been on that journey from the wet lab and the traditional biological sciences training to the types of training and types of skill sets needed for bioinformatics, for handling these large databases. So we have embedded in here a lot of understanding, a lot of empathy, and a lot of consideration of the challenges faced by those with the traditional biological background as they move into this very much new domain. So what then would you expect in this master's program, in this overall postgraduate program? What you see up here on the screen is just a quick snapshot of what the modules would look like. This is how the material would be delivered to you. It's how you would interact with the material. So very much web-based interface, lots of video content, lots of visual content. You can access the content on many different types of devices. In addition to that, we will have live lectures and live tutorials where you'll have lots of live interactions, opportunities to very much connect with the program, with the lecturers, and with the material. Combined with that, we have lots and lots of learnings embedded, lots of different activities, quizzes for you to be able to practice your skills and to be able to rapidly develop these skills as you go forward. And then in addition to that, we also offer all of the material in much more traditional text formats as well for those who might not be super comfortable with these types of. Okay. And then a little bit of a deeper dive into the content. You see here the 6 different taught modules that are part of the program. And then for those doing the full masters, you would have an MSc dissertation at the end. Speaking briefly, modules 4, 5, and 6 up here are the ones that involve programming training. The first 3 modules are biology-based and data-based, bioinformatics based indeed, but they do not have any requirement for programming, although they are peppered with lots of examples of how programming would be used to manage and to work with this type of data. To mention a couple of things here, the 3rd module, bioinformatics methods, this is designed to teach you how to perform a lot of core bioinformatics techniques without having to do any programming. It uses a user interface, Galaxy platform, which allows you to see bioinformatics methods and tools in action without the need to actually have to program. Then the 4, 5, and 6 brings you into the more solid programming components. Some of the languages taught, you'll have seen the connection here between Cormac's presentation and the use of the R, the bash command line, and also Python. So you'll be equipped in this program with all of the key scripting languages that are essential in bioinformatics. The full masters can be completed in 1 year, and it's suitable for any level 8 biology, computer science, engineering graduates. Then finally, what can you do with this qualification? Well, this qualification is designed for those who have a background in biology or in the computer sciences who want to upskill, reskill, and prepare themselves for exciting new careers in the genomic era, post-genomic era. What can you do with this qualification? The qualification has legs. It is designed to equip you with the core skills to be able to evolve and adapt in what is a rapidly evolving landscape. What you see on the screen here is a snapshot, and a snapshot only of some of the companies in Ireland at the moment that are working with genomics data and therefore are doing bioinformatics. This list could be added to, and it will only grow in future years. So just to finish off, if you are interested in the course, please visit our website, as you can see below here, or please, informal inquiries are very much welcome to either Kim or myself. Our email addresses are below. Please also, if you're interested, look out for some actual course content, which will be made freely available from June 24th onwards. So you'll actually be able to see part of one of the modules, and you'll be able to interact directly with the material and get a real feel for what the course will look like. Thank you very much.
Thanks very much, Paul, and to James and Cormac for your presentations today. I think that gives us a real insight into the world of bioinformatics and where we are moving towards. So we've a few minutes for a few questions. If anybody wants to raise their hand or even stick a question into the Q&A box up top. I think boys, you give a pretty comprehensive overview there. There's no questions, or else everybody's just a wee bit camera shy. So we'll not worry too much about that. So as Paul alluded to there, if you have any questions for myself or Paul, the email addresses were there at the very end, and indeed Cormac for anybody that's interested in careers at Randox Laboratories. There are email addresses at the end of Cormac's presentation. So we have Cleo there coming in.
Yeah, Kim, there's just one question went into the question box there.
Oh, okay.
From Erin, how would the diploma fit into the full MSc? So I suppose it's just understanding the different steps.
Yeah, so that's actually a very good question, Erin. So as Paul presented, we have 6 modules and then a dissertation. So the first 3 modules is the postgraduate certificate. Now you can sign up for that, okay? Even if you want to just get a taste of bioinformatics, you can sign up for the 3 10-credit modules. So that'll make up the postgraduate certificate. However, you could sign up for the all 6 modules, and that would be the postgraduate diploma. Now, come the end of that, you might love bioinformatics and you might want to take on the dissertation, which is like a big research project, and that's another 30 credits. So it's very buildable, this here program. So you can start off, if you wish, with a certificate, or you could sign up for the full masters. If you were to sign up for the full masters, you can take an exit award at 2 different points, either at the postgraduate certificate level or the postgraduate diploma level. So that's how the diploma fits in. So you have the diploma and then a 30 credit dissertation tacked on at the end will bring you to the full masters. Well, hopefully that answers your question, Erin. Anybody else? Yes. Well, if you are camera shy or I can't think of a question right now, feel free to send us a wee email and we'll hopefully respond within a few hours' time. But if there's no other questions, I'm just going to thank all the people on our panel today, and thank you to the audience for joining us today, and hopefully it didn't take up too much of your lunch break. Okay, folks, thanks very much for that. Bye now.
Thanks, guys.
Thanks all.
Bye.
Thanks all. Bye-bye. Bye-bye.